which of the two Gaussian surfaces, A or B, has the larger electric flux? So to figure this out, we want to use Gauss's law. Gauss's law states that the net electric flux is the integral of E dot dA equals Q in over epsilon naught, where Q in means the net charge enclosed by the Gaussian surface, which in this case is a sphere. For part A, it's a sphere with radius r. Part B, it's a sphere with radius 2r. If you look at this equation, you might see that it tells you the answer right off the bat. But let's go a little conceptual first, and then we'll come back to the equation. So let's ask, what does net electric flux mean? So electric flux is a quantity that represents the number of electric field lines which cuts through a surface. So for surface A, we have a charge of plus Q right here. We have a Gaussian surface. I'll draw that one with a dotted line, radius r. The electric field, since this is a positive charge, the electric field lines come straight out of the positive. And they extend on to infinity, or they stop at some nearby negative charge. There's the net electric flux through this surface. So the net electric flux, we see there are 1, 2, 3, 4, 5, 6, 7, 8 lines cutting through it. So that gives us an idea of the electric flux for part A. Let's also do the same representation for the electric flux of part B. So there's Q, there's radius r. So let's also draw B, which has a Gaussian surface, radius 2r, net charge of plus 2q. So here's B. There's a charge of plus 2q. Here's a Gaussian surface. I haven't got it quite to scale, but hopefully it's good enough that you get the idea. There's our Gaussian surface, which is a sphere of radius r, and this charge is 2q. Now let's draw the electric field lines. This charge is twice as big, so it has twice as many electric field lines. So with charge A, we drew 8 lines. This charge is twice as big, so here we have to draw 16. So this is the electric field around the charge for part B. If we look at this guy, radius here is 2 times r. If we look at this guy, there are twice as many lines cutting through the surface as there are in part A. Since electric flux is a quantity that represents the number of field lines that cut through a surface, since B has more lines cutting through its surface, it means that B has the larger net electric flux. So from this image, B has more lines through the surface. Therefore, B has the larger flux. Okay, so there's a physical understanding of the question. If you wanted to do it mathematically, it's no problem. That works as well. So if we look at our Gauss's law, and let's think about this term and this term, net electric flux equals Q in over epsilon naught. If we apply it to this situation, so for this problem, QB equals plus 2Q, QA equals plus Q, so QB is greater than QA, so flux of B is greater than flux of A. That's okay too. So either of those explanations is absolutely fine. Last, let's just think of one more implication. If we look at our Gauss's law, if we look at this expression in particular, the area isn't here anywhere. So you might ask, why doesn't the area matter? Let's go back to this explanation and see why the area doesn't matter. If we were to draw a second Gaussian surface on part A, and in fact, maybe I'll just redraw that down here so we don't mess up the picture. So why doesn't area matter? So if we were to draw charge A again here, so plus Q, and the electric field lines we said come straight off. if we draw a Gaussian surface that has this size of a radius, let's call that R1. And then if we draw another Gaussian surface, and let's give it a bigger radius, let's call this R2. We see that R2 is bigger than R1, no problem to see that here. But we also see 8 lines cut through the first surface, and 8 lines cut through the second surface. They have the same number of lines. So that's why area doesn't matter for the flux. No matter how big you make that circle, you'll still get the same number of lines. So the flux doesn't depend on the area of the Gaussian surface. It only depends on the charge inside. Okay, and now in our last video, we'll go ahead and solve this last one. So our answer to this question was surface B. And next we'll go on and solve this one.